In this lesson, we will be looking at an experiment called electrolysis. The word electrolysis means breaking apart using electricity. So electro from electricity, and lysis comes from the Greek word to break apart or to unbind. Electricity can be used to break a molten substance apart. This experiment is called electrolysis. Now, this is obviously a new word to you, so it's worth going through some of the different forms. So the name of the experiment, the noun, is called electrolysis. The verb is electrolyze. So you would say, I am going to electrolyze this molten substance. And the verb in the past tense would be electrolyzed. So we would say the sodium chloride has been electrolyzed. In this context, positive ions are often called cations and negative ions are often called anions. Now, the way I remember that is the word cation. If you look at the T in the middle of that word, it looks a little bit like a positive sign. So that's the way I remember it. Cations, positive, anions, negative. Let's take a look at an example. So it's a very well-known example. It comes up in textbooks very often, and it comes up in exam papers very often. Lead to bromide. So we're going to look at electrolyzing this molten material. So if we take a look at this picture in front of us, we have a negative electrode on the left-hand side, a positive electrode on the right, and those are both dipped in to our molten ionic substance, in this case lead to bromide. So you can see I have my liquid particles floating around in that bowl. And as you know, in a liquid, the particles are free to move. So my positive ions and my negative ions are free to move in this molten ionic substance. The electrodes are normally made of an inert material, and that would normally be graphite. Okay, it could be platinum, but platinum's very expensive. And this just prevents them taking part in the reaction. So we don't need to worry about the electrodes breaking down or reacting with anything during this experiment. The rule to remember is that the positive ions, the cations, are attracted to the negative electrode, and the negative ions, the anions, are attracted to the positive electrode. And the way to remember that is that opposites attract. And this is what you can see in the diagram in front of you. The positive lead 2+ ions have been attracted to the negative electrode, and the negative bromide ions have been attracted to the positive electrode. The negative electrode releases electrons. That's why it's the negative electrode. Okay, so the negative electrode, I always think of it a little bit like a machine gun that's constantly spewing out negative electrons. That's why it's called the negative electrode. So when those positive lead 2+ ions reach it, they take these electrons and they become neutral lead atoms. When something gains electrons like this, it is called a reduction reaction. And this is what you can see in the diagram in front of you. The lead 2+ ions have been attracted to the negative electrode and they have been neutralized. They used to have a 2+ charge. They've now gained electrons and they are now neutral lead atoms. Let's take a look at the positive electrode. The positive electrode is the opposite. It takes in electrons. So I always think of the positive electrode as being like a vacuum cleaner that's constantly eating up electrons. The negative bromide ions lose electrons and become neutral bromine atoms. Okay, so it's very similar to before, except this time the bromide ions with the negative charge are becoming neutral bromine atoms. And there's a general rule there. We're starting with an ion. The ion gets attracted to an electrode where it loses its charge. It's a little more complicated in this situation because you know that bromine does not exist naturally as individual bromine atoms. You know that bromine is actually diatomic. It exists as two bromine atoms bonded together. So, these bromine atoms join together to make Br2 molecules. And as I say, that is because bromine is one of the diatomic elements. When something loses electrons, as in this situation, it is called an oxidation reaction. Now, in the case of these diatomics, you just have to remember it. There are 7 diatomic elements. They exist naturally as two atoms bonded together. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. If you were to colour them in on the periodic table, they would look like the number 7. There are 7 of them in total. Okay. If you can remember that for bromine, in this example, I would say that is an A star or grade 9, depending on the course, thing to know. Okay. A lot of students forget that bromine exists naturally as two bromine atoms bonded together. To summarise, positive ions, cations, are attracted to the negative electrode. Opposites attract. Negative ions, anions, are attracted to the positive electrode. Again, opposites attract. At the electrode, charged ions always lose or gain electrons to become neutral atoms. Finally, watch out for those diatomic elements. Their atoms always join together to make X2 molecules. The diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And as I said, if you were to colour them in on the periodic table, they would look like the number 7, as you can see in the diagram below. A useful mnemonic to remember is oil rig. Oxidation is when something loses electrons. So whenever you see something giving up electrons or losing electrons, that is called an oxidation reaction. On the other hand, reduction is the gain of electrons. So whenever you see something gaining electrons, that is an example of a reduction reaction.